So welcome all to today's webinar with the topic Colorize LiDAR point cloud in 3Dsurvey. As I already explained before, we will play with two different technologies, photogrammetry and LiDAR technologies. We'll try to show you strong points from both technology and the strongest one, how to combine those two technologies together. I will have about 25 minutes for short introduction about my part. Then Maxime will take over and explain you in more details how to work with LiDARs, what kind of systems are they selling it, what kind of results you can get out of it, and so on. Here is the short introduction slide. So first we will see a short topic introduction, what you are going to see today. Then with the second point, we will show you some examples where the LiDAR technology is super strong one. Then we will have a look about the basic workflow with the LiDAR data. Maxime will help you with this. At the end, you will see the added value, what means if you have colorized point cloud from LiDAR or just standard point cloud without colors. And of course, if there are some questions, please feel free, write those questions in chat box already during the webinar, and my colleague Vit, who is also attending this webinar, will answer them immediately. And really interesting questions, we will explain them also then during the webinar. We also prepare a short poll for you, so a few more questions that we get out of feeling what kind of customers we have today on this webinar. And I would love to share immediately my first question, and this one is actually, which industry do you work in? You have 5 more questions available, so surveying, construction, mining, public safety, or other. Let's give you a few more seconds to answer the questions. Of the attendees already voted, so let's close. And if you see the results right now, 65% of attendees are in surveying, 30% in constructions, and 17% in other. Okay, let's go to my second question. And this is actually, how many employees does your company have? So 1 to 3, like a small company, 4 to 6, 7 to 10, 11 to 20, or plus 20. Okay, again, we have more than 60% of results. Let's close the pool and share the results with you. So we have a bit more than 30% with 1 to 3 employees, so small companies, then 40% 7 to 10, and I'm super surprised, 55% of 20 plus employees companies. So really good, really good. It's a professional technology, and that's why also big companies are already there. Okay, cool. My third question is, what is actually your job role? And this is, are you engineer, or are you manager, are you leader, owner, or other? I think more than enough to get a good feeling. Let's close the question and share the results with you. So we have 60% of engineers, 17% of engineers, 3% of leader, 10% owner, and 10% other. Okay, so great that we have most of the technicians here. Our webinars are always super technical, where we can share something with you. The fourth questions altogether, we have 5, so this is not the last one more after this one. And simple question, are you already using photogrammetry software in your daily work? Simple answer, yes or no. And if I close this question right now, we have 93% of you are already using photogrammetry software. Hopefully this is 3Dsurvey. And 7% are still not using this technology. Hopefully you will decide to use it in a short future. Okay, thank you for this. And the last question is, how many times per month are you using spatial data? So I'm not just using, I'm just talking here about the photogrammetry, but also LiDAR, maybe not using the drone to gather those data. Maybe you order some kind of data or you download it from official database, but that you are operating with 3D spatial data and so on. And the answers are once per month, 2 to 5 times per month, 5 to 10 times per month, or more than 10 times per month. So mostly on a daily basis, actually. Let's close this last question. More than 65% of you already voted, and we can see that 30% of you use this almost on a daily basis, or actually on a daily basis. Then 26% of you once per month, and around 22% between 2 to 10 times per month. Okay, super interesting results. Thank you for this question, and let's go further to our presentation. Again, if there are some questions in chat box or anything like that, or question box, please set your questions there. We are happy to answer them. Okay, really quickly, just about myself, who are organizer of this webinar. My name is Marco. I'm part from a 3Dsurvey team. I'm a land surveyor with more than 11 years of experience based on drone technology, photogrammetry, and so on. I've worked on more than 100 projects in this period. I'm also product manager at 3Dsurvey, so I'm directly connected with our product. And because we are doing also a lot of field testing, or at the beginning we did a lot of project for end customer, I'm also drone pilot operator, so I know how to work with them. I also know what are the benefits from specific drones and so on. Today with me is Maxime from TOPODRONE, from Swiss company, founder of TOPODRONE, also surveyor with even more experience that I am, so plus 20 years experience, and again also drone pilot operator. As you will see it later, Maxime has a great product list of products from drones, from LiDAR, which comes together with drones, and it's also our 3Dsurvey partner who is working really well. And today our plan was actually to present you how to join these two technologies, what are the benefits for one technology and the other technology, that you can get a really good feeling what kind of technology implement on some specific projects. I'll directly start with short introduction with the LiDAR technology. In past we have a lot of webinars about the photogrammetry, which is super powerful. But nevertheless, there are more and more projects also really interesting where the LiDAR is super powerful, and that's why I would like to explain a bit more in the future what kind of LiDAR integration is possible in 3Dsurvey. I also need to mention that in the last release, last upgrade with the 2.15 version, we are also able to colorize LiDAR point cloud with the help of photogrammetry. So if you import the LiDAR point cloud from a standard LiDAR drone in 3Dsurvey, you can nicely colorize this point cloud and get realistic colors out of it. Maxime will present this at the end. Then I would like to show you two best applications for drone LiDAR. The one is already visible on your left side of screen, so definitely power lines is a super interesting one. Then in the next part of presentation, Maxime from TOPODRONE will show you how it works, their PPK solution for drones in 3Dsurvey, how accurate can it be, because they are also selling hardware, GPS, PPK, antennas, and software which post-process the data from your Mavic Air, Mavic Mini, Mavic 2 Pro, Phantom 4 Pro, and so on. And you can later on use this data as a post-processing and of course later for photogrammetry processing in 3Dsurvey. Then Maxime will show you how the LiDAR workflow is, so how to operate with LiDAR and what's important there. Let's go maybe to my next slide, and actually one of the best practice application, definitely if you have a long power lines. I'm not going to say that it's impossible to do with a photogrammetry, but it's kind of super hard sometimes. You need to have great overlap. It takes quite a lot of time to process out of it. We have one webinar in past which explain you how to do it. But with the LiDAR, for example, if you have these options, you are just much faster actually for this one. And our suggestion is, if you have a long power lines to map or something like that, let's say like 10 kilometers or plus 10 kilometers, you can easily do this with this application. And if you see this video from 3Dsurvey where we import the LiDAR results in our software, you can see that all cables are visible and the power pole is visible. Of course, you have a lot of terrain points, so main elements from the power line, and if you do a power line inspection, are there, and you can simply continue then with the vectorization and so on. So this is just for introduction. And the second one, super powerful with the LiDAR, is, you know, with the photogrammetry, sometimes you have issues to get terrain points. If you have a high vegetation, with the LiDAR, you always get some points, and you can see here created surface in 3Dsurvey based on ground points, and then the point cloud from the vegetation above the surface. So what's the main point? If you're using the LiDAR technology, you can actually get also terrain surface under the forest, even if the forest is super tight and so on, because every point which goes from the LiDAR, it gets the reflection, and you will always get some points who are going through the vegetation, and then you can create such a nice surface in 3Dsurvey and do then advanced operation in the software calculation of volume calculations or anything like that. Now I would like to give my word to my colleague Maxim.
So do you see my screen right
Yes.
now?
Yes, correctly.
So thank you, Marco. Thank you for a very good introduction about me and about our company. And I would like to say thank you for all participants who find time to join our webinar. And today I would like to show you the real advantage of using photogrammetry and LiDAR technology together to get accurate results. As I can see from our survey before this webinar, the major number of people are using LiDAR technology or drone technology for surveying. And you know, when you make a survey, usually you need to prepare data for future construction. You need to prepare data even in vegetation. And of course, in this case, combination of LiDAR technology and photogrammetric technology provides you the best results. You will easily get terrain level from a LiDAR technology, and you can easily vectorize data with using of photogrammetry if you are going to vectorize roads or buildings and so on. And of course, photogrammetry helps to colorize LiDAR point cloud, and combination of both technologies provides the best results, which I saw before. And before presentation of our data processing workflow, I would like to describe a few words our equipment which we produce, especially in order to convert any kind of consumer drone to survey drone. And first of all, I would like to say the reason why we decided to enter the business of manufacturing of equipment, of manufacturing of hardware. As Marcus said, already said, I have more than 20 years experience in surveying. And it was my dream to have a very lightweight and very easy to use drone. And the price of this drone should be very low. Why? Because when you fly with a drone, every time it is not so dangerous, but of course you can lose the drone. You can lose the drone. In this case, before I searched the market and I was looking for such solution at the market, and I understood that there is no any affordable solution for me. What I can pay for survey drone before, I should pay more than $10,000 or $20,000 to get survey drone, and this is why I decided to invent a drone for me. I just take a Phantom 4 Pro, and I know from my photogrammetry background that Phantom 4 Pro has very good global shutter camera, And after that, I decided if I combine this global shutter camera together with GNSS receiver, what results would I have? And finally, as soon as we made the first integration and we made the first results, we receive accuracy between 10 and 20 centimeters without using ground control points. And 3 years ago or 5 years ago, it was incredible. It was outstanding solution. Why? Because all survey drones cost more than $10,000. And Phantom 4 Pro with additional installed GNSS receiver provides very good accuracy, which enough for surveying, and the price of such solution was very, very low, less than $4,000. And after that, I decided to share this information with all other surveyors, and I received a lot of requests. Is it possible to send such equipment to them? It was very important for them to install this equipment on the drone by themselves. And after that, we decided to produce upgrade kits for the drone. It's just the GNSS receiver, which should be connected to DJI or any kind of drone to capture photo events. And after that, with using of post processing, you will get precise coordinates of the images. And after that, you can make a survey, and you don't need to lay a lot of ground control points. You need just to measure several checkpoints to evaluate the accuracy. And this one, it was the major advantage of such technology. You know, if you use ground control points, you need to lay special crosses or checkpoints with a distance of 200 meters or less to provide a good accuracy. But with PPK technology, you can achieve very good accuracy without using ground control points. And of course, you need to use it like a checkpoints. You need to calibrate the camera to identify a focal length for the camera. It's very important to get very good accuracy in altitude. But in general, it simplifies your survey, and it will help you to cut your expenses in the field. It will help you to cut time of the survey. And within 3 years, we expand our products from Phantom 4 Pro, which was our first solution, to Mavic 2 Pro, Mavic Mini, DJI Air 2S, and of course we have a solution for enterprise drones like DJI Matrix 300, DJI Matrix 200, and a lot of users all over the world are using our equipment right now. And you know, and for me it was like magic to use the drones for surveying, and I don't need to lay ground control points, and I can cut my expenses in the field and data processing. But it was very difficult to make a survey in a forest area. And in this case, I decided, and why we don't invent a very affordable LiDAR solution, which should be very stable and accurate in one hand, and another one hand, it should have very affordable price. And finally, we designed a line of LiDARs which has very affordable price, has very stable and accurate results. And you can use it even in a dense forest. You can use it for volume calculation. You can use it everywhere. And of course, a combination of photogrammetric survey and LiDAR survey will provide you better results and better benefits. And today I would like to introduce our newest solution. It is a DJI Air 2S with additional installed GNSS receiver on board. It has 20 megapixel camera. Together with our GNSS receiver, it provides 3 or 5 centimeter accuracy definitely. And I think right now it is the cheapest, not the cheapest, it is the most affordable survey drone at the market. It has very good 20 megapixel camera. It has mission planning software, so you can use it easily for small areas, like you can cover up to 40 hectares per flight. You will get very accurate results, and of course it is very easy to use, and you don't need to spend a lot of money for expensive survey equipment. And of course we are looking for some high resolution cameras, and we offer different kind of solutions for enterprise drones. Like for DJI Matrix 300, we offer 24 megapixel and 61 megapixel cameras, which are totally integrated with DJI system. You have video link, and we specially designed these cameras to use for photogrammetry and to use it together with the LiDAR systems. Why? You know that if we make a survey with the LiDAR has very huge coverage, and common photogrammetric cameras like P1 has a very short field of view, very small field of view. And it's not so feasible, it's not so productive to use together P1 camera together with the LiDAR, because you need to provide bigger overlapping if you are using camera together with the LiDAR. And this is why we design and we produce right now 24 and 61 megapixels camera with a very good field of view, which covers the same area like a LiDAR. And our integration with the LiDAR is very wide, and we can use multispectral cameras with the LiDAR, we can use high resolution cameras with the LiDAR, and all of them are integrated together, and you will get very accurate results, even multispectral LiDAR point cloud, if you are using multispectral cameras as well. And right now, I would like to show a brief information about LiDAR system, which we have 4 major models of our LiDAR. First of all, it's an entry-level solution based on Livebox sensor on a solid LiDAR. Of course, it has very affordable price, the cheapest LiDAR from our company. And it has a high precision IMU inside, but the quality of Livebox point cloud is not so good. You know that it is a little bit noisy, and geometric characteristics are not so good. And this is why we use high precision calibrated Velodyne sensors. And we offer TOPODRONE LiDAR 100, which is based on a special series of ultra-PAC sensor with the better parameters, with the better accuracy, which provides amazing results and has very affordable price as well. And we offer LiDAR 200, which is based on an ultra-PAC sensor from Velodyne, which has very huge area of survey. It covers 350 meters across your flight direction. So within just 3 lines, you will cover square kilometer. And this year we launched the most accurate LiDAR from TOPODRONE. This LiDAR is based on HDL32 sensor from Velodyne, which has 32 lasers integrated with high precision Honeywell IMU, integrated with GNSS receiver. It provides amazing point cloud in terms of outstanding point cloud, in terms of noise. So it has very small number of noise, and of course it captures very small details. So you will get very detailed point cloud and very accurate point cloud. And our LiDAR systems are widely used all over the world. This one is photo of our LiDAR system, which is installed on Matrix 300, is used in Holland. And our LiDAR system, which are based on Velodyne sensors, can be installed on a backpack or any car or quadro bike, and you can make survey as well as from the drone, or you can make terrestrial survey, you can make mobile scanning, and it helps you to be more flexible. In case if you are not going to fly, you can install a LiDAR on the backpack and you will get the same results. And if you need to cover a huge area, bigger area, you can install LiDAR on the drone and you will survey a huge area from the drone. And TOPODRONE LiDAR 100 provides amazing point cloud, very detailed point cloud, and you can define different small objects like you can see from the screen. And this point cloud is very accurate and very stable. And of course, this one is an example of one of our projects which we made in Riga together with Metron company, and we achieved very good results. And 2 weeks ago, we shared these results during our webinar. You can watch our video from this webinar where we show real accuracy of the system and accuracy of LiDAR 100 in between 3 and 5 centimeters definitely, or even better. And you can easily create 3-dimensional models of power line, power poles. You can measure trees, and you can penetrate dense vegetation to get terrain level under the trees, and you can count trees. And there are a lot of implementation of LiDAR technology. And of course, we compare our LiDAR with terrestrial scanning as well. And here it's an example of terrestrial LiDAR, green one, and drone LiDAR survey, red one. And you can see that we can easily penetrate dense vegetation, and the quality of the point cloud is very good. And of course, our LiDAR can be installed on a VTOL to cover a huge area, like 5 square kilometers per one flight, and you will get very accurate and amazing results. And as you can see, it is better to see point cloud in RGB colors. And this is why we have to find a solution how to combine LiDAR point cloud together with photogrammetry data and how to colorize this point cloud. And this is why we choose 3Dsurvey, because not only of the opportunity to colorize point cloud, but because of the wide tools to vectorize data, to create CAD layers, to create contour lines. So inside of one software, you can create your CAD layers, you can create maps, map layouts. Everything can be done in LiDAR 360. And in the future, in my future part of presentation, I will show the results of using 3Dsurvey software. And of course, you can easily extract for huge areas, even a deep vegetation without any problems within few minutes. And this one example of LiDAR survey as well. And you can see from the terrain, from DCM, you can see a lot of trees are situated in the area, but you can easily classify and you can easily remove trees and you can easily create contour lines. And of course, if we are talking about using LiDAR for construction area, if you are going to use LiDAR to create three-dimensional models of the buildings, if you are going to make high precision three-dimensional models, we would suggest to use LiDAR 100 HDL, which is based on HDL32 sensor, which has very good IMU inside, very good GNSS receiver inside, and it provides very beautiful point cloud. And this point cloud has a lot of advantages, such as very low level of noise, and you can easily capture small details of three-dimensional point cloud. And this power line was captured with HDL sensor, and you can see how clear we reconstruct three-dimensional model of the power pole as power tower and the power lines. And we don't use any filtering of point cloud. It's a real point cloud from this LiDAR. It's amazing, really amazing point cloud. And right now, as soon as I introduce our line of LiDARs, our vault of LiDARs and PPK systems, I would like to talk about data processing workflow. In general, right now, everybody uses drones for surveying. And you know that data processing workflow is very simple. First of all, you need to prepare a mission for the flight. Then you need to install a base station. After that, you will capture images. And after that, within 1 hour, you will make a GNSS data post processing. You will make air triangulation. You can use checkpoints or GCPs to evaluate the accuracy or to rectify your model. And after that, you need to create dense point cloud. And the time of data processing, if you need to create a dense point cloud, is several hours because of the huge amount of measurement due to the photogrammetric data processing. But if we compare the same workflow with the LiDAR, you will have the same steps in the field. You need to choose the area, you need to prepare a mission, you need to install a base station, you need to make a survey with the LiDAR, or you need to make a survey together with the LiDAR and with the camera. And after that, data processing takes less time in comparison with photogrammetry. You need to post-process GNSS data, generate point cloud, make strip alignment if it is necessary, check your accuracy, and it will take you less than 50 minutes. And after that, you will get point cloud, which can be used for future vectorization and for future terrain extraction and classification of the point cloud. And all these steps will take less than 30 minutes for one flight. It's amazing productivity and it's amazing efficiency of a LiDAR. But of course, you need to colorize point cloud. In this case, you need to make steps of photogrammetric data processing as well. You need to get images with high precision coordinates inside, and after that, make air triangulation and colorize point cloud. And if you combine both data sets together, you will get very detailed and amazing results in the future, and you can make maps, very detailed maps and vector layers with using of both data sets as well. Before showing you real projects, I would like to talk why we choose Ppk technology. You know that there are two different technology. First of all, it's real-time kinematic RTK technology, and the second one technology is post-processing kinematic. In general, everybody knows about RTK, but right now, if we are talking about comparison RTK and Ppk, I would say that Ppk is more accurate because you post-process data, you can implement additional filters, you can remove noisy satellites, You can implement additional masks just to remove noisy satellites, remove some reflection, and after that you will get more accurate results. And at the same time, if you are using Ppk technology, you don't need to provide direct connection between the base station and the drone. You just install a base station on the point with well-known coordinates, and you just save RINX files on the base station, and you can fly with the drone within 20 kilometers range from the base station, and you don't need to provide direct connection between the drone and base station. It's very important if you fly in a forest area, if you fly in an urban area, in the cities, and it provides you more efficiency. It provides efficiency and flexibility. And of course, Ppk technology is more stable in comparison with RTK technology. And this is why all our drones, all our equipment work in Ppk, in post-processing kinematic technology. In order to post-process data, you need to use special software. This year, we launched TOPODRONE Post Processing software, which provides you possibility to post-process GNSS data, make image geotagging and matching. You can post-process data even from DJI RTK system, DJI P1, Outtail RTK system. You can process with data, post-process with data, and you will get accurate coordinates of the images. And with using of this software, you can match accurate coordinates together with photos. And after that, you will start photogrammetry data processing. And in our TOPODRONE post-processing software, you can post-process GNSS data together with IMU, which is critical for LiDAR technology. And you can generate point cloud from a LiDAR in real time. And we support different kind of sensors like LiveOx sensor, like Velodyne sensor. And it is possible to use any kind of projection, any kind of geoid to import inside of our software. As a result, you will get georeferenced point cloud, you will get coordinates of the images in your local projection and with using of your geoid. And in order to increase the efficiency of our software, we implement batch processing, and you can post-process several flights together. And if you make a lot of flights per day, like 10 flights per day or 20 flights per day, you can easily post-process it together in automatic mode. So it will help you to save your time in the office as well. And our new software, TOPODRONE Post Processing, faster 10 times than our previous software, TOPOSetter. It has improved algorithms for post-processing. It has additional technology to make PPP processing, precise positioning without any base station. You can convert coordinates as well inside of our software. So everything we decided, and we tried to create total workflow in order to prepare all your data for future data processing and photogrammetric software, for future data processing of LiDAR data in one box, in one interface. And now it is available in with using of TOPODRONE Post Processing software, which is available right now for order. And we supply this software together with all models of our equipment. And right now we will talk about data processing workflow. First of all, I would like to show how to make photogrammetric data processing in 3Dsurvey with using of TOPODRONE Ppk system, with using of our software to achieve accurate results and to minimize your field work, to exclude ground control points from processing and just use one ground control points to calibrate focal lengths to achieve very good accuracy in altitude. So I will show you. First of all, first step, you install your own base station in the field, or you can connect to any available correction network, and you need to download RINX file from this network. And of course, you need to fly your area with the drone. After that, you will choose a folder with images from your drone. You will choose GNSS data from the drone, which is stored in a UBX file. After that, you will add the antenna offset, which is included inside of our software as well. And after that, you need to add a base station file in RINX format or inside of UBX format or any available formats what you have. After that, you should run GNSS data post-processing, and software will create a chart with the results of GNSS data post-processing. Algorithm to match images with coordinates together, and we have very good interface to see if it is matched well. And right now you can visualize your images and position of your images, and you can visualize position of coordinates. And after that, you can match images and coordinates together in more simple way than before. After post-processing, you will get a number of photos with accurate coordinates inside of EXIF text. Additionally, we will create text file with the coordinates in WJS84 coordinate system, and a text file with the coordinates in your local coordinate system, which you choose during data processing. Here in the software, there is a possibility to add your own geoid, to add your own coordinate system. As a result, you will get results of post-processing in your local coordinate system as well. After that, you need to open 3Dsurvey, add images, and 3Dsurvey will import precise coordinates from EXIF text after post-processing of the images. Or you can import coordinates from a text file. You can import coordinates as well as precision of each image. And after that, you need to start aerial triangulation. And aerial triangulation is made in automatic mode. And what you need is just to find type points, and the basis of the type points software will define distortion parameters, internal parameters of image orientation. And after that, you will get accurate model. What you need, only what you need. You know that photogrammetry is very sensitive to focal length of the camera. And this is why we suggest to use one checkpoint, one GCP to update focal length. In this case, you just, in this project, we just add several GCPs to evaluate the accuracy. And one GCP was used like a GCP, and all other points was used like a validation points. And as a result, we achieve such this kind of accuracy. So we use just one GCP to update focal length of the camera to get very accurate model in altitude. And after that, all other points was used like a checkpoints. And you can see that we achieve accuracy between 2 and 3 and 5 centimeters. This project was based on Phantom 4 Pro drone with additionally installed GNSS receiver on board of the drone. And we use this kind of equipment for this project. This one, Phantom 4 Pro, with additionally installed GNSS receiver. The same results can be achieved with using of Mavic 2 Pro, Mavic Mini, and DJI Air 2S, or even with P1 camera, Sony cameras, or TOPODRONE cameras. And what I would like to say, why I like 3Dsurvey software. 3Dsurvey software allows to remove rolling shutter distortion from Mavic 2 Pro camera, from Mavic Mini camera, and from Air 2S camera. And rolling shutter distortion can be removed easily. What I would suggest for rolling shutter camera, you need to fly with a double grid mission. It provides the best results and very stable results. But of course, you can use only simple grid mission for flying, and you will achieve the same results. As soon as we evaluate the accuracy, we start model reconstruction, and after that, I like 3Dsurvey. It provides an amazing point cloud, very detailed point cloud. Even from 80 meters altitude, you can measure road, you can measure any bordure, any kind of objects to create a three-dimensional map. But of course, photogrammetry has one big limitation, is vegetation. And you can see if we use photogrammetry in vegetation, we couldn't achieve a good results if we have a dense forest or dense vegetation in our area. And this is why we would suggest to use photogrammetry together with the LiDAR system. And I would like to show you data processing of the LiDAR on the project which was made by our customer from Costa Rica. He used Matrix 200 with the LiDAR and X4S camera. And X4S camera is connected to the LiDAR as well to synchronize it and to capture coordinates of each image. And you can see Costa Rica has very dense forest, and it is not possible to reach this area by any car, and you need to use a quadro bike. And this is why our client choose Matrix 200, because it's very small enterprise drone, and you can carry in one box, and you can fly even at night with a LiDAR. And after that, he achieved very good results, and I would like to share these results with you. So first step of LiDAR data post-processing. First of all, you need to get precise trajectory of the flight. In order to post-process GNSS data and IMU data, in order to get precise trajectory, you can use our software, TOPODRONE Post Processing, and there is a module LiDAR Post Processing. You just add the data set from the drone. It is GNSS data, UBX data, and IMU data. After that, you need to choose offset of the antenna, and you need to choose the base station and input precise coordinates of the base station. Within few minutes, you will get very precise trajectory of the flight. And after that, you can generate point cloud, and point cloud is generated totally automatically. And this one is an example of this project where our client generate point cloud, and it is not colorized, and it has very good penetration of the forest. And you see that we can easily trace terrain under deep, under big trees, under deep vegetation. And this one example, which I show you data processing right now. And after that, we need to colorize point cloud. And in this case, I would suggest to use 3Dsurvey just to make a first step of data processing, air triangulation, and after that, you can import data inside of 3Dsurvey to colorize point cloud. And this one example of colorized point cloud, the same profile, and you can see how we can trace terrain, how we can extract terrain automatically. This one, it's DSIM. And there are a lot of trees, there are a lot of bushes, and we can automatically extract the tree. We can automatically delete trees, bushes, and buildings. We can classify point cloud, and we can get accurate terrain like this one. And right now, I would like to show you data processing in real time to prove the statement that data processing of the LiDAR is very fast, and you can 10 minutes you will get accurate result of LiDAR data, and you can import inside of 3Dsurvey to colorize point cloud, and after that you can make vectorization in a 3Dsurvey. Why? Because 3Dsurvey has a wide range of CAD tools to create contour lines, to vectorize data, to vectorize roads, and so on. So first of all, what we should do? First of all, we should choose data set from our drone. Our drone save raw GNSS data in a UBX format. After that, we should choose IMR file from the drone. It's a raw IMU data which is stored inside of the LiDAR. After that, we can add the drone model and offset of antenna. This one, just we will choose offset of the antenna. And after that, we will add the base station file, which is stored in UBX format or in any kind of format or RINEX format. We need to add precise position of the base station. And if you need to define precise position of your base station, you can use our model for static post-processing, and it will help you to work in one software. So you can post-process kinematic, you can make it static post-processing, and after that you can generate point cloud as well. And as soon as we prepare our project for post-processing, within few minutes we will receive precise trajectory, and on the next step we will generate point cloud, and it will take us several minutes. And while our software is processing GNSS data in order to get precise trajectory, I can answer your question if there is any questions.
Sure, Maxim. I know it's going to be interesting, but we already know super great presentation. Okay, one question which is directly connected with the LiDAR is, hi Maxim, how many returns of the HDL LiDAR do you get?
2 returns, the strongest return and the last return, and all Velodyne sensor provide 2 returns, and Livox sensor provides 3 returns. But don't consider these options. The main parameter of LiDAR is the penetration of the forest, is the quality of reflection and quality of your LiDAR. It doesn't matter how many returns you have, but if you get noisy point cloud, it will lead to error. In this case, I would suggest to use Velodyne sensor because it penetrates forests in a better way. It provides less noisy point cloud, and if you compare with solid LiDARs, point cloud will be much better. And while I was answering the question, software post-process data and generate precise trajectory of our flight. Do you have another one question for me?
We have another one which is directly connected. And what is the best altitude for the 200 ultra LiDAR?
The best altitude is the working altitude for 200 ultra LiDAR starts from 50 meters up to 150 meters. You can work on all range of altitude from 50 meters up to 150 meters altitude. So a next step is to, as soon as we receive precise trajectory of our flight, which is and it was computed on the basis of GNSS data, And on the basis of IMU data, next step, we will generate point cloud. In order to generate point cloud, we will select raw LiDAR data. After that, we will select trajectory which was just generated right now. After that, we can choose some part of trajectory to generate point cloud. We don't need to use all part of trajectory to generate point cloud, and we can cut some part of turning part of trajectory in order to create less amount of data. And we can choose the area, and we can exclude some part of trajectory in a better way, just to keep only lines. But even we can generate point cloud for the whole trajectory, but I would suggest to cut turning part of trajectory. And after that, we just generate point cloud for these lines, and we can choose any kind of projection. For example, I just import here Costa Rican projection and I use geoid, but you can add any type of geoid here, and you can import any type of projection here. As the result, point cloud will be generated already georeferenced. So you don't need to do any georeferencing of the point cloud. Point cloud will be accurate every time. And one additional thing which is very important, you need to calibrate your LiDAR, and you need to use this calibration. And you see that I have pre-calibrated parameters for the client in Costa Rica, and after that I just click start to generate point cloud. I need to select geoid for correction, and after that point cloud is generating, and it will take us several minutes to generate point cloud, dense point cloud with a million of points within a few minutes. It can be done in real time, as you can see. Why? Because LiDAR, it's a direct measurement, and what you need just to correct point cloud. In the photogrammetry, you need to make a lot of calculations to define distortion parameters, to find out tie points, to find out internal and external parameters of orientation. But with the LiDAR, it is more easy, and the model of the LiDAR doesn't depend on a light condition. Why? Because if we compare with photogrammetry, every time the quality of images influences to the quality of photogrammetry data. With the LiDAR, you can fly at night. It doesn't matter for the LiDAR at all. And right now, we are generating point cloud in real time, in real time. So this one, it's example of this data set, which is a real project, which was made by our client in Costa Rica. He just sent it to me to, he usually asked me to help him to process, but it's very easy, as you can see. And finally, we, as soon as we generate point cloud, we can import it to 3Dsurvey, to Colorize point cloud, and to process data together with photogrammetry. And I will show you right now. So right now, point cloud is generated, and more than several millions of points was created in a very short of time. And as you can see, all data processing of LiDAR is very simple, and it's a fast data processing. And additionally, you can easily extract terrain level. Right now, we create a point cloud. In next step, we will open a 3Dsurvey project of 3Dsurvey, this one. Before I make an aerial triangulation of Ppk camera. So what I made, I just upload images here. I just upload images, and I make a GNSS data post processing and create a list of precise coordinates. I added these coordinates to the 3Dsurvey and start aerial triangulation. After that, I use one checkpoint, and one checkpoint is the base station. It's just a base station, and I define these coordinates of the top of the base station like a point to evaluate the accuracy. And accuracy is very good, just several centimeters. After that, as soon as I make aerial triangulation, first step of data processing, I can go to point cloud, and after that, I just import point cloud from the LiDAR. I will switch off all other layers right now. I will import point cloud. So we have a spare point cloud from photogrammetry, and after that I go to data, I go to point cloud, and I will choose load. And after that I will choose point cloud from the LiDAR, and I will import it inside of 3Dsurvey. And I would say it is the fastest point cloud processing even I see in a photogrammetric software, really. And this one, it's a point cloud from a LiDAR. And right now we can colorize this point cloud in altitude, right, like this one. And we have tie points, dense point cloud from a photogrammetry here. And after that, I just, this one, it's a point cloud from the LiDAR. And after that, I click right button and click Colorize Point Cloud. And software will use triangulated images to colorize point cloud. And as soon as our images are very precisely rectified because of the photogrammetric processing with using of precise coordinates of the images, all data processing is made totally automatically. What you need just to click of the button and nothing else. And software will colorize point cloud within few minutes. Within few minutes, definitely.
Maxime, can I join your explanation in addition, because we have one question directly to connect
Yes.
it to this topic you are talking. So Vasya Brilc is asking how to colorize point cloud under the trees. And Maxime
it's very
already
easy. I will show you. And this is the advantage of 3Dsurvey. Why? Because as soon as you use images to colorize point cloud, for photogrammetry, for the software, it's not possible to create a point like a point cloud under the trees. But it is possible to colorize point cloud from the LiDAR on the basis of the images. And all point cloud under the trees will be colorized from the images. Even you have a 1 millimeter view between leaves, point cloud in this case will be colorized. And I will show it here. Right now, you see that we have very dense point cloud. And it's very good that we don't use orthophoto for colorizing of point cloud.
Thank you, Maxime, for explaining this.
Yes, I think it's clear right now. Yes, but I would like to show you the results of this colorizing. I will remove trees after that, and you will see that all point clouds are colorized. And right now we colorize our point cloud, and I check. And right now our point clouds is colorized from the images. Unfortunately, the quality of the images was not so good. It was a little bit overexposed, but you see that all point clouds is colorized. And after that, I just remove trees and so on, and you will see that point cloud under the trees is colorized, and you can easily trace roads even under the trees. So this is the advantage of the system. And right now, as soon as I add our point cloud, we can compare the accuracy of the point cloud in comparison with accuracy of photogrammetry. Before, I just generated point cloud from photogrammetry, this one, and I will change the representation of LiDAR point cloud to another one color, let's say red one. And after that, we can easily check 2 point clouds I aligned. And you can see that it is amazing accuracy that all point clouds are combined together without any difference. And this one, it's a major advantage of 3Dsurvey. It has very precise photogrammetric point cloud calculation. And after that, you can add your LiDAR data like this one, and you can see that LiDAR data totally overlap photogrammetric data, and all of them are aligned together without any problems. And of course, I don't do any correction in coordinates. It is due to the very precise post-processing and very precise aerial triangulation. And finally, I just switched off point cloud from photogrammetry. And after that, I switched on LiDAR point cloud. After that, I will remove all trees and so on. Next step, I go to mesh and I will create a mesh. And this one is mesh, which is based on LiDAR data. After that, I can create a contour lines. And this one, it's the contour lines of this area. And have a look how beautiful these contour lines and how beautiful and it's amazing to get such point cloud under the trees. And this one is just point cloud from photogrammetry, and you see how many trees and bushes here. And before, if you use photogrammetry in forest area with the bushes, software will define these points like a terrain, but it is not a terrain, it's just bushes, a very dense bushes. So, and after that, we can vectorize point clouds together, and we can create not only contour lines, we can vectorize data set, and we can create cut data. And this one, it's a cut data, which is created by me just within few minutes. We can open cut data, and we can vectorize it here, like three-dimensional cut data, like border of the forest, like buildings here. And of course, you can use advantages of 3Dsurvey, where you have a lot of CAD functions, where you have an X-ray, when you can vectorize walls of the buildings without any problems. And this is why I would suggest to use LiDAR technology together with photogrammetry technology, just to get very accurate results and comprehensive results. So you will get data set everywhere. This is the idea. So this is my short presentation, and if you have any questions, I think Marco can describe in more details how to vectorize data inside of 3Dsurvey, how to use CAD tools, but in general it looks like this one. You can easily create footprints of the buildings, roads, and so on, and you can easily create contour lines and all data set what you need. I think we spent just 1 hour for our webinar. If you have any questions, I will answer.
Maxime, first of all, thank you for this energy. Thank you for this presentation. It was extraordinary. I think you really nicely show you what everything is possible in 3Dsurvey, what kind of great palette of products you have. So I would once again, I think this is super important because, you know, currently there's a lot of changings with the drone from the DJIs, which are available, which are not available. And it's good to know if you don't have a RTK drone, okay, and you would like to upgrade it to a PPK solution, I must say we test the solution from TOPODRONE and it works really nice. It's super accurate. If you do a double grid, the quality is super nice, also with a minimum of ground control points. So you have this option. What I'm super fascinated also, you managed to put this small antenna also on Mavic Mini 2.
Yeah.
We just bought this drone 1 month ago. We processed the data in 3Dsurvey, and our guys, because our company is a head company, comes from surveying works. 3 main owners are land surveyors, but then 1 floor under us is a big surveying company with 10 surveyors, and they are daily processing data with the 3Dsurvey, and they test the data with the Mavic 2 and are super fascinated. You know, if you need to map a 1 building site or something like that, they compare it, the results, with the traditional surveying, with the total station and just photogrammetry. And I cannot imagine if they would have this small antenna on it, how even more accurate everything would be.
Exactly. And what I would say, Mavic Mini has a best opportunity for photogrammetry. Why? Because Mavic Mini doesn't have automatic focus, autofocus. It has a stable focal length. In this case, as soon as you calibrate the camera of Mavic Mini, you will achieve very good accuracy, and you don't need to calibrate the camera. Just add a precise focal length. It was tested 2 years before, and it achieved very good accuracy. It's not so good estimated right now on the market, but it has a very, very good accuracy, especially for the small size survey, like buildings or small land plots. And you don't need to have a permission to fly with Mavic Mini, you know. It's a very good advantage for European roads.
And it's super small. Thanks God we are doing these things affordable to every user. So definitely we will continue working hard to deliver the best product for processing of the data to get accurate results. And we are happy to have that kind of partners that support us also with the hardware, you know, in addition.
Yeah.
So this is with the photogrammetry part. You saw it, how it works in a 3Dsurvey. Then again, if we return to our main topic, the LiDAR and LiDAR integration and so on, I can again maybe share my screen for 1 minute, just a second, to show this example, which was actually in a PowerPoint, which I mean, it's a super fascinating how we managed to extract out the terrain in the forest area and get out the smoothest surface possible to calculate out volumes, terrains, contour lines, or anything like that. So all those processes are automatically in 3Dsurvey, like classification and so on. And if I turn on the surface and I turn on the ground points, so those are just the ground points. Let's just select those one to have a different color later on. I would just like to show you how many points can you actually find there in between. The blue ones, let me just maybe put the point render size a bit bigger. You see one, the blue ones under it are actually penetrated points. And I would join here the opinion with Max. It's not important that you have 2 or 3 returns, important is what kind of quality you have. And at the same, it goes with the point clouds. When you get a point cloud from photogrammetry, it's not important if you have, 100 million or 200 million of points. Important is that the quality of point cloud is good, that you have sharp edges, and we must say that we produce the sharpest one, as Maxime already mentioned in one of his examples, and this is super important. And with this data,
I just want to add, Marco, can I add some sentence? Just when we make a survey of power lines, we test several solutions, solid state LiDARs and Velodyne LiDARs, especially HDL LiDARs. And after that, when we combine different point cloud on the same power pole, we saw that, for example, HDL just saves the points of real position of power pole. But when we add a point cloud from solid LiDAR, we saw like the diameter of power poles becomes bigger because of the noise of point clouds. You see, it's like I don't know, it looks like a weir of something under the power pole. And this is why the main issue is the level of noise and reality of point cloud. For example, you can measure power lines, and sometimes from some type of LiDAR, especially from solid LiDARs, you will get a power line like a 15 centimeters diameter, but it is not reality, it's just noise. This is the idea.
Okay, Maxime, we have few more questions. The next one is maybe the price of the LiDAR technology. I saw on your slide for the 100, it was written $39,000. It's correct one?
No. A LiDAR 100 costs $17,000. Let me show you the screen. This one is our website, and you can go to LiDAR technology and LiDAR systems, and you can see all prices here. And the most expensive LiDAR is HDL, but provides amazing quality. But I would suggest to use TOPODRONE LiDAR 100. It provides very good quality of point cloud, and it has very affordable price. And inside of this LiDAR is improved Velodyne sensor. It provides really very good point cloud. And if we have time, I can show and I can talk about LiDARs several hours, definitely.
Fully understand you. I was together with you on a previous webinar, 4 hours. Yes. So super interesting webinar. We will definitely post also link for this webinar for people who would like to hear more about LiDAR, more from the Maxime, who have really a lot of experience. Is this software free for use for education and research purposes? Yusuf Mosa ask, if you ask for the 3D survey, the price for the full license is 3,000 euros. You can rent it for 200 euros per month. We have some educational licenses and research licenses. Please contact us on info@3dsurvey.si. And of course, you have a free trial available to download it for 14 days period, and not a problem. Another question, is it possible at the same time flight with drone camera and LiDAR sensor? Maybe stupid, not a stupid question. Of course it's possible, and TOPODRONE also have that kind of solution, not a problem. They are actually so that the camera and LiDAR are integrated together, sure.
Yes, of course.
This is also possible. I think we are really good on time. It was a super intensive webinar. Maxime, thank you for showing us all this. Thank you to be partner of 3D Survey. I see you are really doing great stuff also inside of our software. I'm also surprised when I see someone else working with the software and using all this, additional function which software allows you. I think you also have a great product. I heard also that you are super at support. So we all know that this is super important also, not just sell the product and leave the customer there. We as a 3D survey company are doing a lot of efforts on this second part to support you, to train you when you buy the license and so on. And I know Maxime is doing this super as well. We heard already from a lot of our customers who bought later your systems that you offer them good support. And I think this is super important to have a healthy customer then for 10 and 10 and 10 years, so on.
Thank you, Marco. And for me, it's a pleasure to be part of 3Dsurvey world as well. Thank you for your time and for Intergeo when we first met. And you know, when we talk about possibility to integrate LiDAR together with photogrammetry, in the beginning it looks like maybe, but right now we really realize together this integration, and it's very important for our customers. I am 100% sure. It's not only the case to capture the data. The case is to vectorize data and to create a final map, and it's very important for surveyors. And of course, accurate results and everything. When you have a very good workflow, you will simply save your time and you will earn more money. And it is definitely. So thank you for watching us, and thank you for your time. If you have questions, you can send us requests, and we will happy to answer them. Thank you, Marco. Thank you for your software.
Thank you, Maxim, and thank you all attendees to be part of this webinar. See you on our next webinar in 14 days. And if there are some questions, feel free to contact us. Bye.
Bye-bye.